Hello everyone, and welcome back to part 1 of C++ Tetris. Today we're gonna take a closer look at the template we used last time to open a basic window. From now on, the code for the project will be available on GitHub. The start and end of each episode will be marked with a tag, so that you can easily create a branch and start working from there. So, the code is pretty self-explanatory. We call init window to create a new window. We set the frames per second to 60, and as long as the window should not close, we update the game's logic, and then we call begin drawing, and this needs to be called before any draw call. We draw our stuff, and then we call end drawing to actually display whatever we drew. Once the window should close, we leave the loop, we close the window, and we return. Raylib is very straightforward to use. Let's try to change a few values and see what happens. For example, let's try to draw this text at the origin of the window. And as you can see, it gets drawn at the top left of the window. This actually tells us that the origin is at the top left. This is going to be very important in our drawing logic, but more about that later. As you can see, it's very easy to use, but we've got kind of an issue here. We're just calling some free functions that the library defines, and there's nothing that prevents us from forgetting to call begin drawing or even end drawing. If we do that, nothing works anymore and we get an empty window that doesn't want to even close. Don't do this. So as you can see, it's very easy to mess up and forget to call something very important. This is also a C library, which means that it's going to force us to use a functional style of programming. But we're making a video game and we want an object-oriented design instead. So how do we do? What if instead we had a game class that would manage the opening and closing of the window? When the game object is created, a window is created. When it's destroyed, the window is also destroyed. And we can also use the game class to manage our game loop inside of it. From outside, we could also call a tick function that would advance the game's logic internally and also produce a new frame at the same time. Let's create a header file. We'll call it game. And inside we'll make our class game public private. When we create a game object, we want a window to be opened. So we're gonna need a constructor. So we go game. The constructor is gonna take a width, a height, and a string for the title. We're also gonna need to include a string. And now we need a CPP file for the implementation, also called game. We include game.h. And here we go create definition. And here we want to call the init window function of Raylib. So we're going to need to include Raylib and go init window. We give it the width, the height, and the title. But since the title is a string, we need to convert it to a C string because Raylib takes in a car pointer. So we can just call C string. And we also want the window to close when the object is destroyed. So we go to game.h, we define a destructor, game, we'll mark it noexcept, I'll explain why in a second. We implement it, and inside we go close window. If we take a look at our main, we see that we need a function that tells us whether the window should close or not. So in the header, we go bool game should close. We'll make it const because it's a getter. And we make it return window should close. We're also going to need a function to draw and a function to update the game's logic. But we said that from the outside we wanted only to have one tick function that takes care of updating the game's logic and then drawing to the screen. So instead we should make a void tick function, make these two private, and implement the tick function, and it's gonna call both of them. So it's gonna go update and then draw. We also shouldn't forget to begin drawing and then end the draw. Since update and draw are wrapped inside of begin and end drawing, we can be sure that we're never gonna forget calling them. Now we have a really convenient game class. We can declare our game variables inside of it, initialize them inside of the constructor, and then work with them inside of the update and draw functions. Let's take our game class for a test run. We're gonna include it in main, and instead of all of this logic, we just need to create a game class, initialize it with screen width, screen height, and a title, and make a while loop while the game should not close. We go game.tick. And now if you compile and run, you can see that it works, but we kind of forgot something. In the draw function, we kind of forgot to clear the background. So you just go clear background. We'll give it ray white, which is a nice white given by Raylib. And now if we try again, we have a nice white background, just like before. Except this time the code is much cleaner. Let's put a few assertions to make our class even more robust. So we're going to include assert, and when we initialize the game, we want to make sure that the window is not already opened. So we go assert is window ready, and we want to make sure it's not ready. So in case the window is ready and we try to make another one, the assertion will get triggered. And I like to put nice comments with my assertions so that I know exactly what's going on if it ever triggers. We can do the same for the destructor. So we go assert is window ready. And if it's not ready, then the window is already closed. And these assertions are going to make sure that we don't make a mistake by trying to open two windows at once, because currently Raylib only supports one window. I still haven't explained why I marked the destructor as noexcept. In C++, when an exception is thrown, something called the stack unwinding happens. And basically, if the exception is not caught, the objects that have been created before the exception arrived are going to get destroyed, which means that the destructor is going to get called. And it's going to be very bad news if the destructor throws another exception while the first one is already being processed. If that ever happens, the program is going to halt and we're going to get a very ugly message that's not descriptive at all. I'm not going to go into the details, but you can learn more about it by searching stack unwinding. Now we might think that we are done with our game class, but the keenest among you has probably been screaming at their screen telling me to respect the rule of 5. We have implemented our own destructor, and the rule of 5 tells us that if we implement one of the 5 special member functions, we should implement all of them. The special member functions of a class are the destructor, the copy constructor, the copy assignment, the move constructor, and finally the move assignment. But to understand why we should be respecting the rule of 5, let's put ourselves into kind of a special situation. Here I have created a game object, then created a scope, and inside of it made another game object by copying the first one. Let's see what happens if we run this. And it crashes. We get an exception, and it comes seemingly from close window. What's going on? Let's put breakpoints inside of our constructor and destructor, and also in main. Let's try to run this. Make sure you're in debug mode. So we start by creating our game object. So this calls the constructor. It checks the assertion and initializes the window. After that, we enter the scope and create our second game object. But notice that we did not call our constructor, because this assignment is gonna call the copy constructor, which is defaulted by the compiler. And as we're leaving the scope, the second game object is gonna get destroyed, so the destructor gets called. We check the assertion and close the window. And in the end, the program is gonna close, so the first game object is gonna get destroyed. And here we see that close window throws an exception, and it's pretty clear why we're trying to close the window twice. And also I realized that this assertion is useless. Apparently after we initialize a window, this function is gonna keep returning true forever. You would think that it would start returning false after we close the window, but why would things work the way you expect them to, right? So here we're gonna need to find a better way of checking if a window is opened or not. Here I have opened the Raylib cheat sheet. It contains the description of a whole bunch of functions that Raylib provides, separated into modules. And the one we're looking for is getWindowHandle. And this is going to return the window handle if it exists, or a pointer to it. So if it doesn't exist, this pointer will be null pointer. So we can check that to know if a window is opened or not. So here we should go getWindowHandle. And a null pointer is going to result in false. So this assertion is going to trigger if the window doesn't exist. We should also do the same with the constructor. And now if we remove the breakpoints and launch again, we actually have a proper assertion, and we can easily know what went wrong by just reading the comment. This also showcases the importance of good assertions. What is going on is much clearer. Well then, it looks like creating a copy of our game object is a bad idea. How do we do to prevent such a thing? Well, we should handle the copy constructor and copy assignment by deleting them. In our game class, we should go game constant game reference other, and we go equals delete. And this is going to tell the compiler to delete the copy constructor. We should do the same with the copy assignment, delete. And now if we try to go back to main, you can see that the compiler no longer lets us copy our game object. The game constructor cannot be referenced, it is a deleted function. Great, so far we took care of 3 of our special member functions. What about the move ones? If I try to go std move, for some reason the compiler doesn't even want to let us move our game objects, but we haven't even touched our move constructor or move assignment. So why is the compiler not letting us move? This picture is made by Howard Hinnant, and it shows what the compiler generates and what it doesn't depending on what we explicitly declared. In our case, we have explicitly deleted the copy constructor and the copy assignment, and declaring either of those is gonna cause the move constructor and the move assignments to be not declared. So that would explain why we can't move. The compiler has not created the move constructor and the move assignment, which means that we don't even have to explicitly delete them in this case. And this pretty much means that our class is respecting the rule of 5 properly now, and we can start safely using it. But for the sake of completion, I still want to show you a couple of things. Let's try giving an actual implementation to our copy constructor and copy assignments. Like this, we gave them empty implementations. If we go back to our main.cpp, for some reason now we can move. But didn't we say 2 seconds ago that when we implement our own copy constructor or copy assignment, the move constructor and move assignments are not declared? But that's the thing. There's a difference between not declared and deleted. When the move constructor and the move assignment are not declared, they're gonna fall back on the copy versions. Which means that here we're not making a move, we're making a copy. If we want to prevent a move, we have to explicitly delete them. Like this. And now if we go to main, we won't be able to move anymore. But we can still make copies. This is a tricky thing, so you have to remember it. Sometimes when making moves, we think we're making moves, but we're actually making copies. One last thing I want to show you. This blog is made by Jonathan Mueller, and you should read it, link in the description. He talks about the special member functions of a class and how you should use them, the rule of 0, the rule of 5, and notice how he declares his special member functions. We've got the destructor that's marked noexception, and I have already explained why we do this, but he has also marked his move constructor and his move assignment as noexception. Why did he do this? This is because of std move if noexcept. This is used in some standard containers like std vector. If you use this, you can basically refuse using the move semantics if it doesn't guarantee no exceptions. So if we don't mark our move operations with noexcept, standard containers like std vector will not use them. They're just gonna make copies instead. And we're gonna fall back into the issue where we're making copies while we think we're making moves. And this isn't obvious, so you have to be careful. The constructor is also marked noexcept, but there's nothing inherently bad about it. So it's fine. Okay, let's reset our class back to normal. We make these deleted. And there we go. And that's it for today. I know we did a lot of theory stuff and didn't write much code, but it's super important stuff, so you don't want to miss it. In the next episode, we're actually gonna start thinking about our game. Feel free to use the comment section if you have any suggestions or any questions, and the like bar to let me know if you enjoyed this or not. In any case, take care of yourself and see you next video.